When we think of innovation, the mind often leaps to the modern era: rockets, smartphones, the internet. Yet if we rewind the clock to medieval Europe, we find a surprising reality. Many inventions born between the 5th and 15th centuries were so clever, so efficient, that even today, engineers marvel at them. These were not crude tools of the Dark Ages. They were intricate solutions to real-world problems. Blending physics, material science, and sheer ingenuity. Take, for example, the mechanical clock, an age without electricity, without digital computation. Medieval engineers devised a device that could measure time with astonishing accuracy. Early mechanical clocks, like the one installed in Salisbury Cathedral in 1386, relied on a system of gears, weights, and escapements to keep hours ticking consistently. It was not just about tracking prayer times. It was about understanding the rhythms of society, coordinating markets, and synchronizing daily life. These clocks, often monumental in size, were marvels of craftsmanship, with metalworkers and carpenters collaborating to create machines that functioned reliably for centuries. Today's digital clocks might be more precise, but the mechanical ingenuity of those early timekeepers laid the foundation for centuries of technological development. Water management was another field where medieval innovation thrived. The water wheel, a deceptively simple device, transformed energy use for centuries. Mills powered by water wheels could grind grain, press oil, or hammer metal with a consistency and reliability that rivaled modern small-scale machinery. Some water wheels, like the 13th century ones in the Rhineland, used advanced gearing ratios to optimize power transfer. Engineers optimized the angle of the paddles, the depth of the water flow, and the ratio of rotational force to maximize efficiency. Even today, renewable energy engineers study these designs. Recognizing that medieval mills achieved efficiency through materials and placement strategies we still struggle to replicate in some contexts. Engineering was not confined to energy alone. Bridges constructed during the Middle Ages often used stone and arches in ways that modern engineers still respect. The medieval bridge at Pont Saint-Benazet in Avignon, or the Charles Bridge in Prague, demonstrated not only aesthetic grandeur, but also structural brilliance. These bridges withstood centuries of floods and shifting foundations, relying on compression and geometry rather than steel reinforcement. The pointed Gothic arches distributed weight more efficiently than simple semicircular designs, allowing bridges to span greater distances while supporting the heavy traffic of carts, horses, and pedestrians. And in many ways, their designs anticipate modern principles of load distribution and modular construction. Consider the spinning wheel. While it might seem humble compared to high-tech devices, the spinning wheel revolutionized the textile industry. Introduced in Europe in the 13th century, it multiplied yarn production and allowed communities to produce fabrics at scales that had previously been impossible. This wasn't just a matter of speed. It allowed for more consistent thread thickness, fewer breakages, and stronger fabrics. Modern textile machinery owes its efficiency and concepts of rotation and tension to these early innovations. The trebuchet, a pinnacle of medieval military engineering, is another example of brilliance that challenges modern intuition. This weapon, capable of hurling massive stones over distances exceeding 300 meters, relied on counterweights and precision geometry. Unlike modern artillery, which depends on gunpowder and metal ordnance, the trebuchet harnessed pure mechanical energy in a system both elegant and devastating. The mathematics behind its swing, the pivot points, and the ratio of counterweight to projectile were sophisticated enough that engineers today study reconstructed trebuchets to understand energy transfer and motion optimization. Even in medicine, medieval Europe produced tools and techniques that were ahead of their time. Surgical instruments, including forceps, scalpels, and clamps, were meticulously crafted from iron and bronze. Some of these tools maintained design principles that endure in modern surgery. The ingenuity lay not just in the shape, but in ergonomics. Handles shaped for precision, curves aligned for efficiency, and modular designs that allowed sterilization in boiling water, a precursor to modern hygienic standards. Hospitals in medieval Europe, especially in cities like Salerno and Paris, were hubs of innovation, combining herbal remedies, surgical practice, and practical knowledge to save lives in ways that laid the groundwork for modern medicine. Navigation also saw breakthroughs. Astrolabe, a handheld device for determining latitude, allowed medieval sailors to venture further than ever before. By measuring the altitude of stars and the sun, sailors could plot their position with remarkable accuracy. These instruments required a combination of astronomy, geometry, and meticulous craftsmanship. Before the compass became widespread, the astrolabe enabled explorers to navigate oceans with a confidence that modern GPS sometimes takes for granted, yet its elegance and manual precision remain unmatched. Printing technology is another testament to medieval foresight. While Johannes Gutenberg's printing press is usually dated to the 15th century, the ingenuity of movable type cannot be overstated. By allowing the rapid reproduction of texts, this invention democratized knowledge in a way that still shapes society today. Modern digital printing owes its concept to these early presses. The system of individual reusable letters arranged into pages and then pressed to transfer ink represents a mechanical logic that is both efficient and scalable, a true precursor to our age of mass communication. Even mundane tools reveal extraordinary innovation. The medieval plow, for instance, transformed agriculture. Heavy moldboard plows turned soil efficiently, creating furrows that improved aeration and fertility. These plows allowed northern European agriculture to flourish, supporting larger populations and enabling the rise of towns and markets. The principle behind the moldboard, reducing resistance while maximizing soil turnover, is something modern plows still replicate. The medieval plow demonstrates a deep understanding of material mechanics, long before engineers could explain it in equations. In domestic life, medieval kitchens were arenas of inventive engineering. Cast iron pots, adjustable spits, and rotating ovens allowed efficient cooking over open fires. Smoke, hoods, and chimneys were innovations that improved air quality in homes long before modern ventilation standards existed. Such practical inventions, born from necessity, combined material knowledge with ergonomic awareness, revealing a sophistication that rivals many modern appliances in function, if not in automation. Even in leisure and record-keeping, ingenuity shines. Mechanical automata, early clocks with moving figures, and complex astronomical clocks combined artistry with mechanics. The Prague astronomical clock, installed in 1410, still fascinates visitors with its mechanical choreography. The mechanisms demonstrate an understanding of timing, gears, and sequential motion that continues to inspire engineers and designers today. Consider the design of medieval siege engines beyond trebuchets. Ballistae, mangonels, and battering rams incorporated counterweights, torsion mechanics, and precise leverage. Engineers accounted for material elasticity, weight distribution, energy storage in ways modern engineers often admire for their simplicity and effectiveness. Unlike gunpowder-based systems, these machines were modular, repairable, and relied entirely on predictable physical principles. Even the concept of modular design was not foreign to medieval minds. The construction of cathedrals such as Chartres or Notre Dame involved prefabricated stone blocks, template-based construction, and highly organized labor management. Craftsmen used geometry and templates to ensure consistency across massive structures, a principle that underpins modern architecture and manufacturing. Furthermore, water filtration and sanitation systems in some medieval towns were surprisingly advanced. Wells were often lined with stone or clay to reduce contamination. Cities like Paris and London built conduits and pipes that directed fresh water from distant sources, while waste systems were carefully separated to prevent outbreaks of disease. These measures relied on observation, ingenuity, and practical engineering, centuries ahead of widespread understanding in some parts of the world. Another area of medieval ingenuity was in textiles and dyes. Techniques such as woad, blue, madder red, and natural mordants allowed craftsmen to produce vibrant, long-lasting colors. Some dyeing methods involve chemical understanding of plant compounds, pH, and oxidation processes that modern chemists still study for insights into natural pigment preservation. The precision and reliability of these processes reveal an impressive level of scientific observation applied in a pre-scientific era. Even musical instruments demonstrate mechanical brilliance. Organs, lutes, and hurdy-gurdies required careful construction, balancing tension, resonance, and airflow. Pipe organs in cathedrals were intricate machines with bellows, levers, and valves working together to produce complex harmonics. Modern instrument makers still study these mechanisms to replicate tonal quality and mechanical reliability. The medieval period was also rich in defensive architecture. Castles, keeps, and city walls incorporated features like machicolations, murder holes, and concentric layers of fortification. The geometry, angles, and placement were calculated to maximize defensive effectiveness while minimizing material usage. These principles inform modern military architecture and fortification strategies, even though modern materials and technology have evolved. What is remarkable about these medieval inventions is their lasting principles. Many modern tools and machines still rely on the physics and logic that medieval engineers perfected. Whether in energy conversion, material handling, mechanical motion, or information replication, the lessons of the Middle Ages are still relevant. Often, modern designers rediscover what was already known centuries ago. This era also teaches a broader lesson. Constraints drive innovation. Limited materials, lack of modern energy sources, and environmental challenges forced medieval inventors to think creatively. Water wheels harnessed rivers, leveraged animal strength. Trebuchets converted potential into kinetic energy with no gunpowder. The astrolabe turned stars into navigational tools. Every solution was elegant, practical, and highly adaptive. Yet, for all their brilliance, medieval inventors often remain unsung. The watchmaker, the millwright, the carpenter, and the blacksmith operated within a society that prized utility over fame. Their names might be lost, but their ideas endure. When a bridge survives floods for 6 centuries or a plow design continues in modern farms, we see their genius in action. The medieval mind combined observation, trial, and craft. Unlike today, where theoretical models often precede practical application, medieval engineers learned by doing. They iterated, experimented, and passed knowledge orally or through guild instruction. This hands-on methodology produced solutions that were resilient, elegant, and sometimes ahead of their time. And while technology today benefits from electronics, automation, and precise calculation, there remains a humility in seeing that some medieval solutions we still cannot outperform in efficiency, simplicity, or sustainability. Engineers studying water wheels, trebuchets, or astronomical clocks often express admiration for their elegant economy of materials and principles of operation. In some cases, centuries-old designs outperform modern adaptations precisely because they were so perfectly tuned to the constraints of their environment. These inventions remind us that progress is not linear. Our ancestors combined creativity with necessity, producing tools, devices, and mechanisms that served their communities effectively. The Middle Ages were not a dark period of stagnation, but a time of incredible, often overlooked innovation. In reflecting on these inventions, from mechanical clocks to spinning wheels, water mills to moldboard plows, astrolabes to printing presses, we recognize a timeless truth. Ingenuity is universal, not bound by era. The medieval engineer faced limits we scarcely consider, yet their solutions continue to inspire, educate, and challenge us. If you're fascinated by how history shapes modern innovation, by hidden genius that survives in the quietest corners of time, then there is a wealth of knowledge yet to explore. Subscribe to our channel for more deep dives into medieval ingenuity, lost inventions, and the brilliant minds that shape the world we live in today. Each week, we uncover a piece of the past that might still teach us something new about design, engineering, and problem-solving. Because sometimes the smartest inventions were not built yesterday, they were built 8 centuries ago, by hands that understood the world in ways we are still trying to comprehend.